All right, so today we are talking about trigonometric values at any angle. Um, so what we're talking about is this right here is the angle, and then this would be the point xy. So if I'm doing the point 9, -12, that means I'd go +9, -12, and here's my point. And so this distance right here can be found by using the Pythagorean theorem, x squared plus y squared equals your r squared. So it's this value squared plus this value squared will give us our hypotenuse squared because we just created a right triangle. The angle that we're going to be using to find it is our angle right here. So that's the angle of the triangle. So it's always the angle by the origin that you're going to make your sign from. So if you do Pythagorean theorem, you would do like 9 squared plus a -12 squared. Make sure you put that in your calculator correctly with the parenthesis around it. And then if you know your Pythagorean triples, you would know that this is a 3, 4, 5 triangle, and so that makes us 15. But if you did not know that, I'm just going to show you real quick. So you would do 9 squared, 12 squared, and then you want to square root that number right there. So you would just square root that answer. That's how I get 15 also. So what I also like to do is label. So across from the right angle is always called your hypotenuse. So this right here is the h, your hypotenuse. This right here then has to be adjacent, and this is opposite. So our x value is considered adjacent here, and our r value is and our y value is considered the opposite. And then the r right here that we found is the 15. So if you remember from before, and put it up here, your SOHCAHTOA. It also is true for x and y values. Sine is always your y over your r, cosine is always your x over your r, and tangent is always your y over your x. So either way, usually you guys remember SOHCAHTOA, so I would stick with that, but it is the values too right there, the y and r and stuff. So of our angle here, we're going to do the -12 over 15, and you want to reduce that down to -4/5. So then cosine, remember, is adjacent over it. So we get 9/15, which is 3/5. And then tangent's opposite over adjacent, so -12 over 9, which is -4/3. And then you should have hopefully learned last year, but I know that this was like when some of you guys went remote if you were in regular algebra 2. And so cosecant is reciprocal of sine. So that means that if I flip this answer, I'm going to get cosecant's answer. So this is -5/4. Secant is the reciprocal of cosine, which means I need to flip these right here. So 5/3. Cotangent, the reciprocal is tangent. So we're going to use -3/4 there. So to do the next example on here, -6, -12. So I'll go -2 is my dot right here. So if I want to do it this time, I'm going to do 6 squared plus my 2 squared. Squaring and negative is the same thing. So this right here equals the square root of 40. If you want to break that down, remember that would be 4 times 10. So it's really 2 radical 10. So either way, you can do this as 2 square root of 10. That looks ugly. Let me erase this real quick. 2 square root of 10. And here's the angle right there. So from this angle, this is your opposite, that's your adjacent, and that's your hypotenuse. So your sine of your angle is going to be -2 over 2 radical 10. Cosine is -6 over 2 radical 10. And tangent would be -2 over -6. Now you should get in the habit of reducing these, you guys. So this is 1/3. On an ACT, I will tell you, I personally don't care if you leave it like this. The ACT is going to rationalize this denominator. So first they're going to have -3 over square root of 10. And so they're going to multiply top and bottom by square root of 10. So the answer you would see on that is -3 square root of 10 over 10. So the only reason I would do this is so that you can match an answer on your ACT. There's no real mathematical reason that you need to get the square root off the bottom. So it's negative square root of 10 over 10. And then if you want to flip these, I'm going to flip the originals right here because it was already simplified. This was this right here, so that would be negative square root of 10 over 3. And this is just 3 down here. All right, so depending on what location the terminal side of the angle tells you if your trig functions are positive or negative. So we have what I tell my students is all students take calculus. Some people remember if you go in the clockwise, it's the ACTs. So ACTs with an S on it. What this means is that all trig functions are positive. The sine and its reciprocal are positive. This is tangent, and its reciprocal is positive. And this is cosine, and its reciprocal is positive. So you see up here how we are in the tangent quadrant, and look at the two tangent answers. They're positive. Up here, we were in cosines quadrant, and look, the two cosine answers are positive, but the other four are negative. Down here, the other four up here are negative. I think the thing's froze on me, sorry. So these four right here are negative. So we're telling you, so if cosine is positive, what two quadrants would our terminal side have to lie on? So if cosine's positive, it either has to be in quadrants. So this goes 1, 2, 3, 4. So if cosine's positive, it's either in 1 or 4. If tangent is negative, so it's negative in the ones that do not match. So it's positive here, which means it's negative in 2 and 4. 2 and 4. So secant being negative. So secant's reciprocal is cosine. So it's positive in the cosine, which means it's negative and the 2 doesn't match. So 2 and 3. And then if I want to do the cosine is negative. So if sine is negative, and so if sine's negative, so let me write that down first. So if sine is negative, we have to either be in 3 or 4, right? Because sine's positive in all and in its own quadrant. And if cotangent is positive, so then you look at these two quadrants, and which of these two is cotangent positive, and it's quadrant 3. All right. So now we're going to draw triangles given the current information here. So this is telling me my sine's positive because do you see it equals a positive number here, and tangent's negative. So if we have our triangle ASTC, so sine is positive in either 1 or 2. So then you say which one of those is tangent negative in? It's negative in the second. So you need to draw your triangle in the second quadrant here. So we're drawing this right here. So remember, this is opposite over hypotenuse. Your opposite is 8, and your hypotenuse is 17. Use Pythagorean theorem. This time you do 8 squared plus x squared equals 17 squared. And so you're going to be doing 17 squared minus your 8 squared to solve it, and square root that number. And so remember, that was 15. Now this is 15, but you have to pay attention. We're going in the negative direction here, so you'd have to put a negative in front of it. Now we have the opposite, adjacent, and hypotenuse, and you need to write out your trig functions. So sine, cosine, and tangent. So let's see, we get sine would be, it's 8 over 17. Cosine's negative 15. Tangent would be 8 over, so negative 8 over 15. And then just flip them for your other 3 over here for the reciprocals of those, cotangent. So 17/8. Make sure you put equals everything I'm doing. Negative 17/5 and negative 15/8. Okay, so this one right here, I have cotangent. So cotangent is negative, so that's tangent negative. So tangent's negative in 2 or 3. So out of 2 or 3, where is it positive? That would be the C quadrant. So we're going to draw this triangle down in this quadrant right here. So this is 4 over 1. So if tangent is OA, then this is AO. So adjacent's negative 4, O is 1. So finding the hypotenuse gives me square root in 17 there. So writing out our trig functions again. So sine is going to be negative 1/4. Oh wait, just kidding. That's tangent's answer. Sine is 1 over square root of 17. Cosine's negative 4 over square root of 17. And tangent is negative 1/4. Now, if you want to rationalize these, it would look like this. And then we have cosecant, secant, and cotangent. Where do you know cotangent? I'll put it in there anyways, though. And so this would be negative square root of 17 over 4 and negative square root of 17. So the bottom one, I see the thing's frozen again, sorry. So the bottom one, this is cosecant, which means this is sine's answer. It's negative, so sine's negative in either T or C. And then the other part says that cosine's negative, so we're in quadrant T. So I'm going to go ahead and just draw a triangle down in quadrant T down here. All right. And so if sine is OH, then this is HO. So my hypotenuse is square root of 5. Hypotenuse will never be negative. So you're trying to figure out where the negative goes. It's never with the H. And so the 2 is going to be over here. And then we would do square root of 5 squared equals negative 2 squared plus x squared, and solve that, and I get 1. Now, again, I'm going in the negative direction, so I have to put a negative on it. And that's why you know the negative goes on the 2, too, because it's going in the negative direction. So this is your O, A, and H. So writing out my trig functions. Oh, we're going to have to rationalize those. So sine would be the negative 2 over square root of 5, which is the reciprocal of that. Tangent would be negative 1 over square root of 5. And then this, sorry, cosecant, cosine, I can't even speak today, sorry. And this would be a negative 2 over negative 1. So this is a 2. If you wanted to rationalize this, which I'm fine not rationalizing it, but if you have to, it's square root of 5 over 5. And this is negative 2 square root of 5 over 5. And then cosecant theta, secant theta, and cotangent theta. So doing all the reciprocals would be negative square root of 5 over 2, negative square root of 5, and 1/2.